And welcome everybody to the Daily Space Weather Show. We've got some action finally happening here. We had an M-class flare late last night. You can see it in the western hemisphere there. And don't worry, we'll show you a little closer views than that. These are 24-hour videos from the Solar Dynamics Observatory. So that is a long-duration M-class event. There's also some plasma filamentary reorientation happening, some minor coronal mass ejecta. The primary thing you're seeing there is a Hyder flare when plasma splashes back down toward the solar chromosphere. So there's an extreme close-up of that. How you like them apples? And let's look at another 24-hour video. This is 304 angstroms by itself. That's just ionized helium at about 90,000 degrees Fahrenheit. We also have had some sunspot growth over in the eastern limb especially. I believe there'll be a new named group to the northeast of that northern group that just rose up there. So there is a little bit of an increased likelihood of continued large solar flares. And a few different regions there that are likely to produce large solar flares. So here is colorized magnetogram. These SDO browse data sets of images are yesterday, August 22nd, through today, August 23rd, to date. So a little bit of an uptick there, and let's take a brief look at what's going on planet Earth. So first, erupting volcanoes. Mount Mayan continues to erupt, producing a 9,000-foot plume of volcanic ash. 10,000-foot plume of volcanic ash there over Karengatang. It's a flight level 100 as Karengatang explodes. Luatolo, 7,000-foot ash plume there from Luatolo. Nevado del Ruiz, 20,000-foot ash plume. It looks like an uptick there in Colombia as Nevado del Ruiz explodes as well. Flight level 200. Flight level 230 over Sabancaya in Peru. And flight level 230 over Ubinas. Those are both 23,000-foot altitude plumes of volcanic ash. Ubinas and Sabancaya both exploding in Peru. And let's take a look at seismicity next. And folks, it's important to look at the troughs, not just the peaks. So when it comes to things like space weather, heliophysics, etc., the troughs are just as important as the peaks. And, I sort of stumbled upon the mechanism likely underlying the solar sunspot cycles due to the peaks, aka solar minima. So that's a little tidbit for you there. We are seeing a bit of a 7 magnitude earthquake drought, and we're seeing an earthquake drought in general here. The number of 5 or greater magnitude earthquakes over the past 24 hours has been 0. So here is a big lull in earthquake activity here. 0, 5 or greater magnitude earthquakes over the past 24 hours. So quite a few there around the Pacific Rim. Keep in mind, if you're in any of those zones, any earthquake can be a foreshock. We are seeing some on the west coast of the U.S., one in Texas, it looks like. So just be aware of that. Any earthquake can be a foreshock. And let's head back to space here. Here is the past 24 hours from SDO 171 angstroms. Now that is the house favorite wavelength. It shows the lower corona, and it does a great job at showing all of the potential field surface source lines as that hot ionized iron emits ultraviolet radiation in the extreme ultraviolet spectrum. And that hot iron likes to align to magnetic fields down there in the lower chromosphere, the lower corona. And let's talk stats. The 10.7 centimeter radio flux now at 151 solar flux units. And the 10.7 is the most proportional data that we have to sunspot number. So as you can see in this 1 year chart, the radio flux represented by this black line The sunspot number represented by this red line. The blue line is the AP index, which is an average of the KP index. Just an average of global geomagnetism. And in the pink line here is the 30-day sunspot numbers. The 30-day sunspot number average, known as the Wolf number. Space Weather Enthusiast dashboard here not calling for any geomagnetic storms or geomagnetic unrest in the coming days. We'll talk CMEs later in the video. Let's take a look at Earth geomagnetism next. Here's Earth's magnetic moment from space for the past 4 hours. We have seen a subsiding of the solar wind speed here in the past couple of days, coming down from all the way around 680 kilometers per second. Now much slower than that, around 450. We'll show all the details on that. That's the past 4 hours of Earth's magnetic moment from space to about 12 Earth diameters. Here's Earth's magnetic moment from the ground, showing magnetic flux density. Again, it is a geomagnetically calm situation on planet Earth. This will show you the most likely places to see the aurora when there are geomagnetic upticks. Telluric currents, pipeline, railway, and power grid induction. Also the likelihood of aurora on that imagery. KP index currently at 0.33, so very low geomagnetism there. The planetary K index is an average of geomagnetism on a global scale. The planetary K index, KP 0.33 at the moment. And let's look at the real-time solar wind. And just a quick reminder that it's measured at Lagrangian point 1, orbiting that gravitational equilibrium point at very low fuel cost. Current conditions are pretty unremarkable here. About 427 kilometers per second for the solar wind speed. Solar wind density here about 5.25 protons per cubic centimeter. GOES magnetometers here pretty smooth over the past 24 hours, following a little bit of a shake-up there during a high-speed coronal hole wind stream. So if you look at the 7-day chart, you can see a couple little variations there, but pretty calm as far as the GOES magnetometer measurements. The arcjet moments are the GOES satellites turning on their thrusters to maneuver. That plasma can create erroneous data for the magnetometers. Next, our top view ecliptic plane field plot, and Earth is still in a south pole current sheet. And this data makes me think that that sunspot in the northeastern limb is going to continue to grow. So again, I think there's going to be a new named group to its northeast. We'll show you more details on that here momentarily. Here's the latest image, and you can see the south pole current sheet has extended. So we can expect another day or two of south pole current sheet. Just keep in mind the magnetic environment can suddenly change with basically no warning. If you're getting any, it's probably from our channel. So there is the North Pole current sheet there. Again, it's still a couple days out, assuming nothing suddenly changes. Here's our line of sight field plot, the solar B field depicted in blue, north solar polar field in green, south solar polar field in red. Grayscale depicts the Gong magnetogram, and quite a bit of magnetic organization on the Earth side of the solar disk. Next, coronal holes. There's our coronal hole line of sight field plot. We've got more North Pole coronal holes here rotating in the northeast. Those will become more well-defined in the coming couple of days. And here is the past 24 hours in SDO 211 angstroms. You may also notice a major plasma reorientation coming from this area right here around the time of that M-class flare. So that's sort of a common thing. Large plasma filaments have a tendency to eject, reorganize, anchoring themselves in a different location, and sometimes they just collapse. That was actually a combination of mainly reorientation and collapse. So up here we can look for some more coronal holes moving in. Again, they are of North Pole orientation. Next we'll move to sunspots. Here's the sunspot situation. Again, likelihood of large solar flares is going up, and the main change is up here in the northeast. So Also, the top view ecliptic plane field plot suggests that those will continue to grow up there, so that's sort of a forecast. The area to the northeast of 3413 may continue to exhibit some interesting growth, so let's take a look at what's been going on here for the past 24 hours. There's the SDO continuum. And you can see a little bit of umbral growth up there. Besides that, things are pretty stable. We've got a wide range of latitudes at which sunspots are appearing, and we're still like nearly a year out from solar maximum. Don't expect the lull in activity to continue. And let's move on to solar energetic particles and solar flares. No solar energetic particle events associated with that M-class solar flare last night. Again, it happened late night around... Peak flux was around 2310 Universal Time. It was only an M1 class flare. And let's take a look at our flare wavelengths. 94 angstroms is a great portion of the electromagnetic spectrum to view solar flares. 94 angstroms depicts ionized iron. It is extreme ultraviolet light, by the way. It is not X-rays itself. 94 angstroms along with 131 angstroms take 5 times more images than the other wavelengths. They're specifically formulated to view solar flares. And there's the equatorial zoom. And there's this, here comes this long duration M-class flare. Right in there, great view of that. What's that? You want a closer view? All right. Another 24-hour video for you there. And we'll also show that in 131 angstroms. That's another species of ionized iron, by the way. It is still the extreme ultraviolet portion of the electromagnetic spectrum. So higher energy and shorter waves than visible light. This portion of the electromagnetic spectrum does not make it to the ground level either. You got to be above the mesosphere to see it. That's why we're viewing it via the Solar Dynamics Observatory, AIA instrument. How you like them apples? That's pretty sweet, right? Next, we encourage our viewers to look up, and when doing so, it's always nice to see what's going on up there. So we like to put together a star chart. This is what's going on over Lehigh Valley at the moment. Venus here has risen ahead of the Sun, the third brightest object. And then Jupiter, sometimes the fourth brightest object. Sometimes Mars is the fourth brightest object, depending on their location in the solar system. And you've got Saturn setting over there around the western ecliptic. Also Sirius, the brightest star visible from Earth. The brightest raw star, at least. And you can also see the brightest intrinsic object visible from our solar system, the tail of the swan, Deneb, the only known cosmic ray point source. Next, we'll do a solar system forecast. This is where things are today. We'll advance this 1 week. There's where things will be in a week as we approach the August blue moon, the second full moon in the month of August. Next, let's classify a galaxy here at Zooniverse.org. Zooniverse.org's Galaxy Zoo project requires humans to classify galaxies, so let's classify this one here. This is a galaxy with features, certainly. It is not an edge-on disk. There is no bar visible in that quite irregular galaxy. I don't see any features indicating spiral arms. Is there a bulge? I'm not going to say there's a bulge at all. Are there bright clumps? Well, certainly there are. I would say there is I think that's a merger going on there, as I see 2 bright cores. So that's probably a fairly well-evolved galactic merger happening. Again, AI is unable to do these classifications, so we need people like you to do it. Just set up a login and go classify galaxies yourself thusly. And what do we have here? Do we have a ring? No. Lens or arc? I don't think so. Irregular for sure. Dust lane. Maybe some overlap. Looks like some central diffraction spikes. And there you go. That galaxy has been classified. Will that next irregular galaxy be classified by you? Check it out at zooniverse.org. Many citizen science projects available there. It's the largest citizen science project in the world. Today's astronomy picture of the day is actually, that is a Perseid meteor trail. You can see part of it in the time-lapse imagery there being broken up by winds in Earth's atmosphere. And the different colors depicted there indicate the chemicals that it's made of. That's M31 down there, otherwise known as the Andromeda Galaxy, making its way into the frame. Great image there of a Perseid by Joe Pedrero. apod.nasa.gov if you want to check it out yourself. And let's move on to coronal mass ejections. So here are yesterday's images. We have been having a shortage of coronagraph images for some reason the past few days. We don't think any of those are earthly directed, but if they are, they will only have minor impacts. There may be some small earthly directed components there. That's 62 frames from yesterday. Here are an additional 14 frames from today. And it looked to me like if there was a CME generated associated with that M-class flare, that it would be off to the southwest. So here's Soho Lasco C2 and C3. They're unfortunately lacking data as well. Suboptimal. But don't worry, we do have some imagery for you. So we'll also look at Stereo A's difference imagery. Keep in mind, Stereo A is practically in line with Earth at the moment. But sometimes it'll have data that we can't otherwise see. So here is Stereo A's coronagraph. And let's advance this to yesterday evening. And unfortunately, it ends before midnight. So that's not going to show us anything. Looks like an energetic particle event there striking Stereo A. Here's Soho Lasco C2 and C3 to the extent that we have data. So let's move them manually as well. So here is around noon yesterday, and unfortunately around the time of that M-class flare, not a lot of data available. So let's look at our custom coronagraphs. Here's a 24-hour video. It looks like most of that plasma just reoriented and splashed back down toward the chromosphere, succumbing to gravity, as magnetic fields are responsible for suspending those huge plasma filaments. And gravity is responsible for pulling them back down toward the solar chromosphere. The chromosphere, by the way, is the layer in between the sun's surface, the surface of the solar body known as the photosphere, and the main portion of the atmosphere known as the corona. So there you can see a plasma reorientation happening. There is a filament down here that appears to also collapse. And those features that show brightening, those are largely Hyder flares. That is when the plasma splashes back down. You can also see coronal holes there temporarily opening up. That does likely indicate a sudden variation in the sun's magnetic fields there, but those coronal holes close back up quickly as well as that plasma reintegrates and the system tries to reach static equilibrium, as does everything in nature. Next, here's some totally sweet imagery from Lermonth, Australia's ground-based hydrogen alpha telescope. Massive plasma filaments still especially on the western limb there, and not as many as there used to be. But there are still some there that could get names. This one up here is absolutely massive and very, very dense. It has been there since it rose in the northeast. And of course you can see one of these filaments going away down here. I don't think it ejected. So that's the view from Lermonth, Australia. Here's the grayscale view, which does show quite a few prominences, especially in the southern hemisphere. And if you want to name filaments after living people, join us over on Twitter. Follow the hashtag #NameThatFilament. And that is where I do the most of my social media interacting, over on Twitter. It's slightly less pathetic than Facebook, I suppose. It's still extremely pathetic. And yeah, there's a lot of nonsense on there. And I don't know, there's no way to curate your feed. Twitter curates your feed for you. You're going to see a bunch of posts that you don't necessarily want to see. But follow the hashtag #NameThatFilament. Follow the Space Weather crew, and you will see some updates that you won't see anyplace else as we retweet things that people are saying. People like Scott McIntosh and Dr. Keith Strong and Tamitha Scove. So here are the past about 2.5 hours before we get to our bonus feature segment. Sort of the most current imagery here from the GOES 16 SUVI, looking at 304 angstroms ionized helium. And let's move to bonus features. So bonus features, starting out with satellite charging hazards, there aren't any. It is smooth sailing for satellites. No high energy electrons building up inside of circuitry, and no low energy electrons building up on the outside of spacecraft. GOES electron flux here coming up off the floor as forecast. There's the past 3 days as the GOES 16 and GOES 18 use radiography to measure the electron flux from their near geosynchronous equatorial orbits. Here's the one-year graph to put the electron flux in context. It is measured at the F layer of the ionosphere, which is located at about 300 kilometers of altitude. Here's the forecast model. And NOAA expecting a little downtick and then a significant uptick. I'm not so sure about the downtick, but we have seen the most recent uptick there. The green boxes are the forecast and the yellow diamonds, the observation. The layer that it's measured at is the F layer of the ionosphere, the bridge between Earth and space. It's located at about 300 kilometers of altitude. Here's the vibrational frequency of that layer. And I don't suspect we'll see any major anomalies here. Certainly did see some high frequency ones happening. And let's take a look at the anomaly gram to clear that up. Here's the anomaly in megahertz from the 30-day median. High-frequency anomalies depicted in blue, which is showing quite a few high-frequency anomalies here and some significant ones. Low-frequency anomalies there depicted in red. That's the previous day, courtesy of Australian Government Bureau Meteorology. We'll let that play through one more time and then show the latest image. And then show the total electron content forecast. There's the latest image, 10 o'clock universal time for the ionogram, and there's the anomalygram for that same time. Total electron content is free electrons from ground level to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with these distances in miles. These are the most likely places to see GPS errors. We don't only show the global scale, we'll also show the North American anomaly from the 10-day average. We'll let that play through one more time. If your GPS is likely to produce errors, try Wi-Fi location accuracy. If there are Wi-Fi hotspots, their physical locations can be used to improve your navigational precision. And here's what's going on for North America. This is the North American total electron content anomaly from the 10-day average. And things are pretty normal there. Let's close out the space weather section of the video before getting to meteorology with the latest intensitygram, and there is the latest colorized magnetogram. So again, we've got some growth up here, so let's take a look at that first. That'll be a new sunspot group up there to the northeast of that main umbra. It is beta gamma class. And the larger sunspot group to the southwest of that is also beta gamma class. There might be some small deltas in there. We'll say it's beta gamma delta class. This group down here, also beta gamma class. And this group here, where that M class flare was emitted last night, it's beta gamma delta. It's beta gamma class, but barely. So a prime example of how sometimes a sunspot without major complexity can produce a significant solar flare. That M1 flare came from that region. So let's move to meteorology here. And we're going to start out by looking at sea surface temperature anomalies. We'll show you all of those, and ocean currents. So here is the current situation, along with sea surface temperature anomaly there. The Gulf of Mexico there, anomalously hot. So let's zoom out here. We'll show all of the planet's oceans. There is the Atlantic. There's the Arctic Ocean. Looking anomalously cold in the Arctic Ocean as summer draws close to an end here, pushing toward the final month of summer. There's the Pacific Ocean, the world's largest surface heat sink. It is anomalously warm around the equator. Also the Western Pacific anomalously warm. Southern Ocean anomalously cold, like the Northern Arctic Ocean. The Southern Ocean there, quite on the cold side. And the Indian Ocean, anomalously warm. Also the Red Sea and Persian Gulf there, quite toasty. So let's take a look at winds. Here are the surface winds of the east. Here are the jet streams of the east. Jet streams of the central world. That's Africa, Europe, and the Middle East. Blowing backward, by the way, over the northern Indian Ocean. Here are the surface winds of this side of the planet. Surface winds of the Americas. And as we zoom in closer and closer to the lower 48, there are the jet streams. Huge anticyclone continues to rotate clockwise here over the central U.S. You can see that upper level high pressure zone, bringing clear skies to the area below it. It's not really a heat dome, it's more like a heat depression, as there is a pressing down of that dry, massive air. Why? Because of atmospheric nitrogen, mainly. Nitrogen, it's more massive than water vapor. So here is our satellite view. Give that a minute to spool up. There we go. And we do have some lightning over North Dakota. Also the northern Great Lakes showing some lightning. And this is what's going on for clouds and fog. We use a shortwave radiation map because it depicts clouds and fog at nighttime, and it is still dark here as the sun is just starting to illuminate the sky over Lehigh Valley, Pennsylvania. As we produce this video, there's what's going on. And let's take a look at weather warnings. So mainly heat warnings here. Also a little bit of flooding there in southwest Texas. Also Alaska showing some warnings there. Also Hawaii, if your location is lit, weather.gov is where to get your weather warnings. Weather.gov, the homepage of the National Weather Service. And here comes some forecasts. So this is the 72-hour GFS pressure and precipitation forecast. You can see systems are circling that anticyclone there, which is centered over someplace around Oklahoma and Arkansas. Here is our total accumulated precipitation forecast. That is in inches. It's also the GFS model. Next, the GFS 72-hour temperature anomaly forecast in degrees Celsius. You can expect those hot temperatures in the central part of the country to continue around the Mississippi Valley and so forth. Also spreading to the east a little bit there with some anomalously hot temperatures. Last but not least, the jet stream forecast. Again, it's a 72-hour GFS 250 millibar forecast. The jet stream will remain around the U.S.-Canada border here, mostly staying north of the U.S. And next, lightning. So this is the past about 10 hours. And you can see lightning kind of on the edge of that anticyclone there. You can see that clockwise rotation in control of the U.S. weather system. Here's a real-time lightning map. And the most significant lightning here is in northern Michigan, as far as U.S. terrestrial strikes. Northeast of Traverse City, west of Grayling. Next time you hear thunder, check out lightningmaps.org. It could save your bacon. And smashomash.com could save your bacon too, because we do all kinds of stuff in addition to these videos. Yeah, if you want additional content, you can get it at the Smash Team site. And welcome to the Neo Renaissance. Congratulations on realizing the channel exists. If you click our links, you may find some great buys. One of the things you can check out is the Red Bubble Shop. Today's featured product is our best seller. Do not pole vault the caldera. So that's a public service message for you. And of course, today I'm not wearing the Do Not Pole Vault the Caldera. I'm wearing Smasher Price, my first pandemic. So maybe check that out as well. That's one of the first merch items that we put out. The best seller, this is what we call bandwagon advertising, folks. Our best seller is Do Not Pole Vault the Caldera. So this public service message brought to you at massive personal risk and expense by Smash staff and I. If you're going on a volcanic vacation, leave the vault pole at home. And if you're going through hell, keep going. That's a quote from Winston Churchill for you. Our finest days lie ahead. So don't do your field events around volcanoes. If you're going on a volcanic vacation, leave your vault pole at home. Don't pole vault the caldera. It could be unhealthful. We don't want our viewers to become a portion of the lithosphere. Another link you can find is the link to our Amazon shop. Today's featured product is the GoWise air fryer. If you ain't got one, save 40% on an air fryer. This one in purple. Our kitchen would be quite incomplete without our air fryer. It is fantastic. Amazon.com/shop/smashomash, linked below the video, as well as on the homepage at smashomash.com. Another link you can find there is to the Hemp Lucid shop. So if you're shopping for Hemp Lucid stuff, help support the channel by picking up your Hemp Lucid products through our affiliate link. Also available below this video in the description and on the homepage at smashomash.com. Thanks to our paid affiliates/sponsors and those who are effectively sponsoring the channel, increasing the probability that it will continue to exist, remain publicly visible, and free for all to view. We'd prefer to keep these videos in existence. So why not help us out if you're already a shopper or if you haven't tried the products? And the best way to help the channel out is by becoming a member of the Smash Team. The best value is the gold annual paid up subscription. Thanks to our gold and silver members especially, there is also a bronze level. We send out email alerts for videos just like this one. You can also find original music there on the Spotify link. You can find us on Instagram, etc. Smashomash.com/smashteam is it's kind of like Patreon, just superior because it's got superior capabilities. So if you want to get additional content that nobody else gets to see except Smash Team members, then become a member of the Smash Team at smashamash.com/Smash Team. We'll close out by saying, don't forget to press like and subscribe. Thanks to our new viewers. Thanks to our old loyal viewers. Press that subscribe button and do yourself a favor. Get the world's most comprehensive daily space weather content and the most detailed solar imagery you'll find in the known universe. We do meteorology segments as a value-added service. Thanks to each one of you. Don't forget to press like, subscribe, share, and leave a comment, whether nice or mean. We appreciate it. So here is the U.S. Doppler radar situation, and our weather station shall focus on the lower 48. So there is the U.S. Doppler radar map for the lower 48. Here is the clouds and fog scenario. Again, you can see that clockwise rotation over the central part of the country, and it'll be even more obvious on the water vapor map. A bunch of dry, massive air there, kind of centered over the Tennessee-Arkansas border, somewhere around that area. So here's your recap to close this video out. U.S. Doppler radar showing vertical motion as measured by ground-based Doppler radar stations. Shortwave radiation as measured by the satellite, the NASA GOES interactive weather satellite suite. And here is the water vapor map. That should clear things up if your Doppler is unclear. And we hope you're able to forecast your own weather. Thanks for tuning in. Congratulations on realizing this channel exists. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back.